Today we're going to look at examples of two-way tables. Let's review what a two-way table is. A two-way table is a table that examines the relationship between two categorical variables. Please, please, please do not let this simple word here, categorical, stress us out. That word just means category or categories. So we're looking at two categories and just comparing the relationship that they may have. So here's an example. Here we are looking at one category of gender, male, female, and types of cars, sports utility vehicles or SUVs, and sports cars. Here you are looking at two categories and looking at the relationship that they may have. In this case, the relationship that female males have versus the type of car that they drive. Sometimes you will get the total. To get the total, you add up the row, and then that is the total number there. Same thing, let's erase that because that's a lot going on. You can get the totals down by adding down there and adding down there, and that total should match. So again, sometimes you'll be given totals in your frequency or two-way table, sometimes you won't. Now let's look at examples. A group of children and adults were polled about whether they watch a particular TV show. Okay, simple. The results are shown in the survey, and it shows the joint relative frequency and marginal relative frequencies in the two-way table. What is the value of X? Well, I looked at my question, what is the value of X? And I know joint relative frequencies and marginal relative frequencies, I'm not sure what those are, but it simply wants the value of X. So that information isn't important. I can find the value of X. So I'm looking for this. And I have my totals in this table, and the total for adults is going to help me. It's 0.3 or 0.30 total adults. 0.25 already responded yes, so I can just find the difference or subtract and get 0.05 for X. That's one way I could do it. Let me change my colors. There's another way I could do it. What if I chose to use the no information? The total for no is 0.45. 0.40 children have already been surveyed, so I can just find the difference and get the exact same thing, 0.05. So what I like about these, it allows me to check my work. Let's do another example. Here is a table that shows the number of rich and poor people in Arkansas and Kansas. So states versus rich and poor are my two categories. What percent to the nearest percent of people in Arkansas are rich? Well, I see I don't have totals, but I'm only going to get totals of what I need. And in this case, I need totals of Arkansas because it wants to know how many people or the percent of people in Arkansas are rich. So my total of people surveyed from Arkansas was 1,012. Percent is the key word there, so I can make a percent proportion. Percent always goes over 100 and part over whole or is of. So let's just fill in what we have. The whole amount surveyed from Arkansas was 1,012, so that's my denominator. I'm looking for percent, so I'm putting an X there. Always over 100, it's 100%, the maximum amount. And then the part that I'm looking for, well, I'm looking for rich, so that is the part that goes there, 402. And now I have a proportion that I can solve by cross multiplying, butterfly, if you will. So to cross multiply, 1,012 times X is 1,012X equals 402 times 100, 40,200. Divide to get X by itself, basic equation, and I divide by 1012 and I get 39.7. So it said round to the nearest percent. In this case, we'll say 40%. Let's do one more example to be clear. Using the same information about Arkansas and Kansas. Of the people surveyed, what is the relative frequency that are poor? Relative frequency is just another way to say the percent. It just wants it as a decimal. So now I need total of everything because it says of the people surveyed. So I already know Arkansas had 1,012 people surveyed. I need to find Kansas amount, and I get 802. And I need to add those together because I want all of the people surveyed. What are poor? What is the decimal amount, the percent that are poor as a decimal? So poor, my column for poor, I need to get those total because that's part over whole, 1,037. So here's my proportion. Part over whole equals percent over 100. Again, butterfly method for solving a proportion by cross multiplying. That's an 8 equals 1,037 times 100. And that's 103,700. And now I have to get x by itself. And I get 57.2. So I want that as a decimal because it says relative frequency. Here's my percent, and we know to change anything as a decimal, we move the decimal to the space, to the left, 2 spaces. So that is my relative frequency. I hope you found this video helpful. If you have any additional questions, ask your teacher.